All right, chapter 2, section 2, translating between words and math. And by math, I mean like numbers. That was neat. Numbers and symbols. So like what are those numbers, what do we call those in words as opposed to writing a symbol? So if you notice, I'm going to jump over the first two examples and we're going right to this chart and then we'll come back up to the examples in a minute. If you notice, the front side chart looks very similar to the back side chart. Okay? But the difference is we have algebraic expression here and we have numerical expression on this side, okay? So that's the biggest difference between the two sides. The word part, though, will be pretty much the same for both, so we'll probably only write it once. Meaning, when you see that addition sign there, what does that mean you're going to do? Like, what does that mean for us? What do you think?
We're going to add.
Okay, we're going to add. So to take the word add out, let's try to say that without the word add.
Addition.
Or addition.
Find the sum.
Find the sum. Okay, let's try it this way. How about, have you heard put together?
Yeah.
If you have 2 and you want to put it together with 3, you put those two together, you have a total of 5. Or combine. That's kind of the meaning of what you're going to do with addition. And subtraction, you're going to find out how much more or less something is. So how much more you have or how much less you have, that's what we're going to do when we subtract. We'll jump over to division because that's probably the next least confusing one. When you divide, you separate, or you could say break apart, into equal groups. So when you divide, you break things up into equal sized groups. For example, there's 5, 6, 7, 8, 9, 10, 11, 12. There's 12 students in here. If I brought 24 cookies, how many cookies would each of you get? You do a division problem. You put the cookies in groups of 2, and then you'd each get 2 cookies. Multiplication. I'm not a huge fan of how they have it here, but because I think we all know what multiply means. But the book definition is put together. So we're still doing the putting together. So both addition and multiplication is putting together. Put together groups of equal parts. So when you think, I think the best example maybe this is, maybe not the best example, but if you go to a restaurant and there's 10 tables and there's 8 chairs at each table, right? We're putting together groups of 10. We're going to make them all equal size, 8 chairs. How many chairs do we have total? You have to do 8 times 10. So that's kind of the multiplication piece. Again, the meaning of multiplication in that sense is probably the most confusing of the 4. More importantly, though, how do we write these things? So when you write an addition problem in a numerical expression, not algebraic, numerical, so that means we're going to have all numbers and symbols. 37 plus 28. That is a numerical expression with addition. You've written hundreds of those in your life. Okay? Hundreds of them. Subtraction. 90 minus 12. You've probably also written hundreds of numerical expressions with subtraction as well. Multiplication. Write this one at the top because I've got like 4 different ways to write multiplication in here. So save some space a little bit. 8 times 48. You can write it like that. We could write it with a dot. In numerical, we could put parentheses around one of the numbers. Or we could put it around the other number. Because a number next to parentheses means multiply. One other way numerically, if you put parentheses on around both numbers, it also means multiply. So multiplication has lots of different ways to write it numerically. Have you seen all of those ways before or not?
No. You should have some yesterday.
I showed you some yesterday, but that was with algebraic ones. That was with letters. The probably newest one to you is this double parenthesis one, right?
Yep.
Two parentheses next to each other with no symbol between means multiply. Okay? I don't know why multiplication got the most shortcuts, but it did. Division. Let's not do that number. Let's do 327 divided by 3. That's probably the most common way you've seen things. Yesterday we also said you could write 327 with a slash and a 3. And the other way is to write it as a fraction.
Under the garage. Or the box around it.
You could do the garage. Yeah, we did talk about that one yesterday too, didn't we? The garage one is probably the least common you're going to see going forward. Because we're going to use calculators to do our division a lot now instead of by hand. So we're not going to need to use the garage as much. So you're going to write it the other ways. The most common way you're probably going to see it from now on in math is going to be like this. Like this, the fraction probably most common, using the division symbol, second most common, and third most common is probably using the slash in that order. Okay. All right, so let's think about these. Let's just focus on the addition one. What words do we use when we say addition? When we say add, what do we use? If you're going to read that 37, then there's that sign there, that symbol, and then 28. What words would we use?
Plus.
How would you read that? Read this box right here.
37 plus 28.
I heard 37 plus 28. There's a word we can use. How else can we read it? How else could you read that?
If you actually write the numbers out.
Okay, if I wrote the numbers out. But what can we use instead of the word plus? What can we use instead of the word plus?
37 added to 28.
37 added to 28. I've got two more.
37 and 28.
Not and. You gotta have another word in there because I'm not sure what operation we're gonna do. We're gonna add, subtract, multiply, or divide when you use just the word and. How do we? It starts with an S. The sum of 37 and 28. And I got one more. It's very similar, not really very similar. I'm going to start with the number 28. And then it's a two-word thing. The first word starts with an M, the second word starts with a T.
Mental math.
No. More than 37. If you said 28 more than 37, wouldn't you write it that way? 37 plus 28? Those are different ways to say addition. Okay, now let's do the subtraction one. This guy here. 90 minus 12. You're going to need all of these on your homework, so I would write them down.
12 less than than 90.
12 less than 90. Jackson? No? Faith?
90 subtracted to 12.
Yeah, we're going to flip that one around. We're going to say 12 subtracted from. Twelve subtracted from 90. I've got two more.
What?
The difference of 90 and 12. And take away 12 from 90. Notice that order is important. We wouldn't want to say 12 minus 90. It's not 12 minus 90. It is 90 minus 12. We wouldn't want to say take away 90 from 12 because that's not what the problem is. What about multiplication? Aletta?
84 times 84.
8 times 48. Good. 8 multiplied by. My next one starts with the letter P. The P-R-O product. Product of 8 and 48. Last one, which is probably the least common that you've heard, is 8 groups of 48. It's that grouping one we talked about.
I've heard that one.
Have you heard that one before for multiplication? It's probably the least common of them. All right, division. I only have 2 of them. Maybe come up with more, but what do you think?
320 divided by 3.
327 divided by 3. What do you think, Ben?
The quotient of 327 and 3.
Quotient of 327 and 3. Okay, so that is numerical expressions. Notice we had numbers in all of these. That's numerical. And we had a symbol. The symbol can be represented with words. Now we're going to go on to the back side. Algebraic expression. What's different between numerical and algebraic? Billy?
Algebraic has letters and numbers instead of just numbers.
Yes, algebraic has to have letters and numbers. So we're going to make this really simple. We're going to take the same examples we used for our numerical and we're going to replace one of the numbers with a letter. So algebraic expression for addition. Let's do x plus 28. I have a letter and a symbol. So it can be algebraic. Let's try k minus 12. This one you could write multiple different ways. 8 times w with a dot. You could write 8W just next to each other. You could use parentheses. You can put parentheses around both, just around one of them. Notice I'm not writing it with the, this is what you're not doing. You're not doing it this way. Because that looks like 8xW to me, not 8 times W.
Really?
I mean, you could read it either way, right? It's confusing. So we're getting away from using our x's for multiplication.
If that was then it'd be like 8 times a number times another number.
Yeah. Yep. If that was an x. But if it was multiplication, then you have to do just 8 times W. But we don't know. So that's why we don't use it as much. Or we really stop using it when we do algebra as a x, as the multiplication. I know. We'll get there. Division. Again, probably two ways that you're going to see it. N divided by 3 or N over 3. Those are probably the most typical. You might see the slash there. But most often you'll see the first two. The only difference in our words here, we are not going to write them all again because that'd be a lot of writing, and I think that would take time that we don't need to take. The words are, instead of writing 37 plus 28, you would have just written x plus 28. So I'm going to just say this. See above. Okay? Those words work both the same for algebraic and for numerical. All right? Example 1. Write a phrase for n subtraction sign 4,000. Who wants to give me a phrase for that? What do you think? N minus 4,000. Wants to give me another phrase for that one? Yeah, Aletta, go ahead.
N less than 4,000?
Think about that. Is n less than 4,000 or is it 4,000 less than n?
Oh, 4,000 less than.
Yeah. 4,000 less than n. Are there any other ones we could do? There's lots of them, right? What about my next one? Example 2. Write 2 phrases for that.
50 times S.
50 times s. Good. Aletta.
50 multiplied by S.
50 multiplied by s.